Unit 6-7 with operations of polynomial functions and then composition of functions. So if we have two sets of ordered pairs here or tables of values, we already know how to do function notation, right? So we already know that if we wanted to find f of 1, it's asking us to find the value of the function f of x when x equals 1. So if we are presented with a table of values, all we would do is find x equals 1 and find the value of y, or f of x. Okay. If it does to find g of 9, we would just look at the set of ordered pairs, so the table of values for g of x, find where g was 9, and then look for the result. Okay, or we might even be asked to find two values and add them together, or subtract or multiply. So I might be asked to find f of 0. So f of 0 is 3, g of 0 is 1, and then we would just add them together. So those are pretty easy to do. We already know how to do those. Finding values with function notation, and we know how to do that with ordered pairs, with graphs, and with equations. Okay, so we're going to look at combining functions. So we can combine functions by adding, subtracting, or multiplying them together. There's a little note here about the domain. So the domain, and I'll talk about it a bit more once we look at a graph or some equations, but the domain would have to be the domain that is common to both functions, okay? And I wouldn't worry too much about domain because we're not really going to ask you about that on a task or a test. And we'll look at it a little bit later, but just so you know, the domain of the combined would have to be the domain that's common to both. Okay, so what do we mean by adding? So here I have two functions, f of x and g of x, and I want to add them together. Okay, so I want to add f of x plus g of x. It doesn't matter what the equations of these functions are. We don't really concern ourselves with what the equations. All we want to do is pick points on the graphs, and we're going to add those points together. So you can only add points that are vertically lined up. So for example, g of x is this line here. It looks like an absolute value function. That's g of x. And then f of x is this sort of piecewise function here. That's f of x. And I want to add them together. So I'm going to pick points that are vertically lined up. So I mean that this point here on g of x, which is at negative 0, negative 4, has to vertically line up with a point on f of x where the x values are the same. Okay, so in order to add or subtract or multiply 2 points together, the x values have to be the same. Okay, they have to have the same input to produce an output. You can't add a point here with a point that's over here, okay? Because the input's not the same, so it doesn't make sense to add them if your input is not the same. So we're going to add these 2 points together by adding the y values. So 0, negative 4 plus 0, 1 would be 0, negative 3. So the x will stay the same, and we're just adding the y values together. Okay, then I'm going to pick another point. So maybe I'll pick a point somewhere on the right side. So perhaps I'll pick this point here. So this point here on g of x is at 3 and negative 1. And then I want to pick a point on f of x that is also at 3. And then I look for the y value. Well, that point looks like it's 3 and 1, 2, 3, 4. So if I add those two together, the 3 stays the same. And I add the y values, 4 and negative 1, that makes 3. So 3, 3 would be about here. And then I'm going to pick a point on the left side. Maybe I'll pick this point. So this point on g of x is 1, 2, 3, negative 4, and 0. And then I need a point on f of x, which is also at negative 4. And that value is 2. And so when x is negative 4, y is 2 plus 0, so 2. So that's that point there. And then if I kind of join them up, my graph would look something like that. So graphs are not as accurate, obviously, because you're sort of sometimes estimating where the points are, but try to use points that are easy to read off the graph, okay? And you try to use a point, always try to use a point on the y-axis, and then maybe a point or two on the right and a point or two on the left side, and then that's your best estimate. Okay, and then we could also subtract the graphs by subtracting the y values. We could multiply the graphs by multiplying the y values, right? So we can perform all three operations with this graph. We're not going to do division because we do that later towards the end of the course. We do that in Unit 15, 16. Okay, so we're just being adding, subtracting, multiplying. You could also be presented with some ordered pairs, right? So this is very similar to a graph, except they've picked the points for you. So in order to add f plus g of x, so what does that mean? That means add f of x plus g of x. That's the same thing. We're going to look for points that have the same x value. So here I see a point starting with negative 1, so I look for a point in g of x that also starts with negative 1, and there is one. So that first point I can add together. When x is negative 1, I add the y values. 6 plus 3 is 9. And then I'm going to look for another point. So the next point is 2. Is there a point in g of x that starts with 2? Yes, there is. So I can add those 2 points. When x is 2, I add negative 5 and negative 3, and I get negative 8. Then the next point starts with a 4. Is there a 4? Yes, there is. So I'm going to add, when x is 4, y is negative 18. You'll notice that I'm not using 311 because there is no point in f of x that starts with a 3. So I can't add that point with any point in the other set. Okay, if you are subtracting, just remember order matters. So f of x minus g of x is going to give me a different result than if I did g of x minus f of x. So I can use the same points because I know the x's are the same. So when x is negative 1, this time I'm doing 6 minus 3. And when x is 2, I'm doing negative 5 minus negative 3. And when x is 4, I'm doing negative 11 minus 7, which is negative 4. Okay? I can also multiply the functions together. So I can do f of x times g of x. So we could use the same points. When x is negative 1, I'm going to multiply the two y values together. And at 2, I get 15, and at 4, I get 77. Okay, so with ordered pairs, it's pretty easy to look for the same x value and then perform the operation on the y value. Just a note about f of negative 1x. Remember that this is the inverse symbol, right? This is the inverse function of f of x. So I just want to review what that means because we will be using the inverse function in this unit. So the inverse function, the definition, is the reflection in the line y equals x. So what does that mean? Well, if I were drawing, if I plotted y equals x on a grid, it means that whatever x is, y has the same value. Right? So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is negative 1, y is negative 1. And so that creates a diagonal line through the origin. And so the definition of an inverse function is the reflection in this line y equals x. So that's the mirror line. So let's say I had a function that looked like this. So I had a point here, a point here, and a point here. And I wanted to draw the inverse. So what I do, in order to find the reflection in the line y equals x, so since we're reflecting over that line, all we have to do is switch x and y to find the inverse. So this point here at -2, 1 gets switched to 1, -2. That would be its reflection there. This point here at -1, 0 would become 0, -1. And this point here at 0, 3 would become 3, 0. And then I would get the reflection would look like this. So there's a reflection of f of x, right? That's reflected in that mirror line y equals x. So if you have ordered pairs, you just switch the x and y. If you have a graph, you just switch, you pick points and you switch the x and y. If you have an equation, which we'll look at in a minute, you will switch x and y, okay? So if I were finding, if this function was given as f of x and the points are -1, 6 to, is it -5, 4, -11, and I wanted to find the inverse function, I would just switch. -1, 6 would become 6, -1. 2, -5 would become -5, 2. And then we would have -11, 4. So it's easy to do. You just have to remember what the definition is. Okay? So the third way we can represent functions are when we are given equations. So this question gives you f of x is 6x plus 7 and g of x is 2x minus 5. So they're naming the addition as h of x. So h of x is f of x plus g of x. So all we do is we take the two equations and we add them together. So we'll just simplify by collecting like terms. And that's all you can do. You remember that you can't solve it because it's not equal to anything, right? So we don't have any value to this. It's just an expression. And then it asks us to find h of -4. So we'll just sub in -4 into the end result. So what's that? -32. -32 plus 2 is -30. Okay, so we just sub it in. Sorry, I was thinking of something else there. Okay. Also, just keep in mind that you could, if you wanted to find h of -4, you could sub that in before you added the functions together. That's what I was thinking. So you can add the two equations first and then sub it in, or you could sub it into each equation, each part individually, and then add those two numbers together. Right, so here's an example of that, where I'm subbing in -4 into each individual function, and then I'm going to add the result together. So what would that be? -24 plus 7 is, what's that? -17. And then we have -8 minus 5, -13, and that gives me -30. Okay? So it is possible. I think it's easier to simplify the equations first and then sub it in, but you will end up with the same result if you do it the other way. Just remember that order does matter. So especially when you're subtracting. So 2x minus 5 minus 6x plus 7. Just make sure that you put it in brackets so that you don't make an error with the signs, right? That subtraction belongs to both terms. And then we will collect like terms. Okay, and then it just wants us to find h of 2, so we'll just sub that in. And that that gives us negative 20. Okay, so easy peasy. You just have to make sure that you are following the proper order, right? If I had been asked to find f of x minus g of x, I would have had a different result. And then you can multiply the equations together. Right, so we could do 2x minus 5 times 6x plus 7. So just, if you're going to make an error, it's going to be with your multiplication or your sign error. 6 2s are 12, 14, 30. So we end up with minus 16x minus 35. Again, we can't solve it, so we just leave it. That's my simplified expression. Okay. All right. This is the same sort of thing. H of x is f of x minus g of x. So I'm just putting 2x squared plus 3. And then 5x minus 7. Again, making sure I have it in brackets. And that will change the sign. And then I just collect like terms. Okay. And then just be careful expanding. That's a square. Is that a square? Yep. Okay, so just be careful expanding. Be careful of your powers. Be careful of your signs. 15. Can't talk and write at the same time. Just tidy that up. Okay, so that is adding and subtracting and multiplying functions. Given the data is presented as ordered pairs or a table of values, the data is presented as a graph, or the data is presented as an exponential function. Okay. I think that is where we'll stop for now. Just let me check my calendar.